Good. Amazing. Sorry for the confusion. So it's only one day event too. We really blew it. So I'm Patrick McFadin. I'm Chief Evangelist, but I'm also a solution architect with DataStax. So I get to run into all kinds of crazy stuff.
I'm Tobey. I'm also open source Evangelist at DataStax, formerly of Yala, and broke Cassandra in every possible way, mostly on the ops side.
I think that's what it comes down to. We've broken it more than you have. But we fixed it. So we had our first question in the hallway, in transit. Wow, we packed the room right on. Hold on. Nice job. First question was, how do I scan all the rows in my column family? You do? Aha! Not stumped yet.
Didn't say it was pretty.
No, it's not pretty. It's not performance. But damn if you can do it. There is actually a recipe with the Ask Annex driver called GetAllRed. And the idea is that because it's not just going to be in order, and that's probably the thing I have to qualify. This is not going to be an in-order operation. If you're using random partitioner, it's random.
Doesn't it actually generate all the tokens?
No, what it does is so what happens is that whenever you create a row key, it will hash it into a token value. And then those token values are assigned to each node. Well, because each node has a token range, what you do is you just iterate over that range. You ask for tokens in that range. And you just keep going next through that list. So you're iterating over the range of tokens and backfitting to the keys that are in there. It's not pretty, totally doable. This is how you run Hadoop on a column family. Hadoop needs to see everything in the column family. So the MapReduce jobs, what they do is the mappers actually, when they're spawned, they are given a range of tokens to iterate over. And so each mapper gets a little chunk. So that's why it's efficient there. That makes sense there. But if you want to write code to go scan the entire table, it's doable. Actually, you can do it in parallel too, because the range is it's a well-known range. It's 2 to the 128. So if you have 16 threads doing it, you can break it into 16 threads or 16 different ranges of tokens and iterate over the entire row or column. Or you can use the Ask Annex recipe.
Well, generally you want to, before you get into that boat, I mean, if you think you're going to need that down the road, just keep the second column family. And keep your row keys in a second column family somewhere so that you can do range scans. You want to maybe bucket it, or depends on your data, right, how you're going to do the data model, but that really helps.
That's the only way to keep it in order, for sure, or using order for partition.
Order for making important is bad.
Right.
The entire table.
Right. That will happen. All right. That was a good first starter. See, everyone's like all loose now. Okay. You had your hand up way early.
As I understood, the lists are not efficient for many use cases because they are limited. So, and as per the blocks, it is written that the lists are thread safe. So, because when I have to delete from a list, what do? Is I read all the values and then find an index, then delete, and then from the blocks documentation, we said that this operation, because when you read a whole list and then delete and then put it back, so it can happen that multiple threads get this list and then they remove the indexes, and indexes may be incorrect. So you may remove incorrect elements if you do by application side.
Are you talking about a collection?
Collection list, yeah.
You can remove individual parts of it.
Yeah. But the thing is that, are they guaranteed thread safe?
Yes. It's thread safety versus atomic and isolated are two different things. So.
Okay, so I logically think of same thing. So if two threads are saying, if one thread is saying minus, so let's say two threads are doing minus plus minus plus minus plus minus plus, would list remain in the order that is expected, or?
Yes, because what you're doing is you're deleting individual rows. It's just setting tombstones.
No, I'm not.
Or you're changing it or whatever.
It's a removal of columns now, because list would be the same partition.
List will be the same partition
and all the columns are values.
And they're all values, and it's composite underneath. The storage engine is a composite. So if you're removing values, it's setting a tombstone. The tombstone has a timestamp. The timestamp is what's going to make it win or lose. So if you set the data, remove it, or anything, all those things happen in the order that they would get.
I can reproduce where the list is not able to maintain the order. What would be the reason then?
Then I'd like to have that.
Are you inserting and deleting at the same time?
I'm doing the minus plus. So now at the same time, it's a very confusing word. But I say
the same keys?
The keys, row keys same because it's a list.
Right.
But values are different. So what I'm doing is minus plus, and I can see maybe once in a roughly 30 attempts that the list order is not the way it should be.
Is that
And I can
indexed,
reproduce
is that get indexed on the storage engine?
It's ordered. There's a comparator that orders it. So if the comparator gets confused, this is where I'd like to. You and I talked about this before. You were going to send me the outline of how it worked. So I'd like to try it out because if that really is a bug, we can fix it, right? But why don't you submit the patch? That'd be nice.
I think I can reproduce. I will definitely send maybe.
It sounds like it's probably a race on the timestamp though.
It could be. Yeah.
Our values are UUIDs. These are our values.
No, I mean the index inside your collection.
Yeah.
When you write the tombstone and then you write a new value and then you delete and then you write a new one.
Mm-hmm.
If that happens really,
Yeah.
millisecond, right?
Really fast.
It has to be very, very fast.
Yeah.
But you could get the same counter value or the same time record twice.
This is the time UUID, but okay.
The value is.
The value. Yes.
But the index inside the collection isn't necessarily the storage.
The timestamp inside there.
Right.
So
Yes.
we'd like to try it out.
I will reproduce. It's a single Cassandra node and single thread requesting. So it is very simple case, but still list doesn't have the order.
Okay.
I will.
All right, good stumper.
Well, I want to understand.
You're next.
Yeah.
Sure.
Cassandra on EC2, we've got a nice little production cluster of 12 nodes, and what we're seeing is that sometimes out of the blue, read latency spikes, write latency spikes, and it looks like routing issues, but AWS is quite transparent about it. The problem is that a slow node really manages to bring a whole cluster down. That node doesn't. As soon as we disconnect that node, the cluster is behaving perfectly, but a slow node is really bringing the whole cluster to a crawl. How on earth do you debug that?
Okay, so couple of questions. What client are you using?
Node.js, Hellenis.
Okay, Hellenis. I've seen that before when all of your connections seem to be going through one server mistakenly. So that's one thing to look for. And because you really have no awareness of what node you're connected to, unless you're asking, then you can get hotspotted. You'll go through one node.
That's shuffled, so
If that's the case. So that'd be the first thing to look for. Because I've seen it where one node gets all the connections, and then all of a sudden that one node goes through GC, and it looks like it's across the burn net.
Is the slow node hitting disk at all?
Sorry?
Is the slow node hitting disk at all, or is it just slow? As in, it's serving requests on a memory. Is it hitting disk?
we haven't completely checked that out yet.
Because I've seen that in EC2 before, where a node EC2 basically what'll happen is nodes will be working fine one day. The next day you get a couple noisy neighbors, and all of a sudden your disks go from performing just fine, they just kind of drop off and never come back again, and you have to replace the node.
Are you seeing OS level performance problems too? Operating system level? No.
Okay.
You guys are together, obviously. Or you just know.
Yeah, that's why I was asking if there's any.
Yeah, you guys are talking about it beforehand. You're like, yeah, we'll get going. That'll be great.
It's 2 on 2.
2 on 2.
Fair.
There you go. Anybody else want to join in? Oh, I knew it. You're always bringing problems. All right. Well, I mean, those kind of problems, because distributed computing is a hard problem, hard problems to troubleshoot. But I would look at like, is it really the entire cluster going bad? Is it OS? Is it disk? Is it at that level, or is it increased latency with something else? And
What size instance are you running on?
XL.
XL? That's an M1?
M1 XL.
that's what I would
fine.
consider the
Yeah.
minimum size.
Yeah, because what I've noticed is we started out on the C1 larges, and those were terrible. They drop like flies. We lose one a week, or at least one every other week. The M1 X large is quite a bit better. If you go up to the M2s or just a little bit bigger, what happens is you get into a different class of machine in Amazon, you get into the newer, shinier part of their data center, and they don't have as much variability in them as the older instances do. So anything in the 1 class is going to be in the old part of EC2. And in the 2s and 3s, that's on the newer gear, on the newer network where they fixed all the crap that makes EBS break every year, right? So, I mean, if you've been on, well, there's a big, you know, Reddit is down and the whole world is scrambling EBS outage every year, right? And they're trying to fix that, and they're doing a good job. It's just, it's only on the new stuff because they can't exactly evict all their customers off of the old gear to fix it. So that's why I always recommend, whenever possible, go with the bigger and the newer instance types. Not because they're shinier, but because you're going to get the better infrastructure. And then your database is going to be a lot more consistent.
Would you recommend going to M3, so EBS instances?
Well, not EBS at this point, no. The ephemerals are actually pretty much perfect for Cassandra because you have the replication built into Cassandra and you can replace a node pretty easily. So
I've never had a good experience with EBS on
It's like
Cassandra
having-
EBS.
well, I think he's meaning the guaranteed IOPS.
The guaranteed IOPS are not that good either. I thought, well, because IOPS are irrelevant. It's transfer speed. How long of a sequential operation you can run? What's your max megabytes per second? Yeah, you can get some really good ones with EBS, but they're not consistent and they just don't keep up as well as what you can do with a stripe set on ephemeral. You take 4 disks and you do a RAID 0 on those, you're going to beat anything that Amazon can give you. That's just it. Next question. You already asked, Dan, so I'm behind.
So
One at a time.
I haven't been keeping up well with hint and handoff. I know it's changed across different versions. What's the latest state? How does it work in the most recent versions of Cassandra?
Well, not really changed.
Changed much since 1.0, right?
What changes are you talking about?
Well, just stuff I read.
Well, all right, so
in
there's-
terms of the mechanism.
Yeah, from 1.1 to 1.2,
Right.
the biggest change was that how hinted handoff is managed from a dropping out. So, for instance, if mutations were dropped in 1.1, then potentially the hints would be dropped as well. So this is the worst case scenario. So just kind of level set, hinted handoff, what this is all about. Very normal part of a Cassandra ring operation. So when you have multiple nodes running and you have coordinators, so whenever the client connects to a node, it may not be the home for that data, and they need to that data needs to go to other replicas. So that node will act as a coordinator. If one of the replicas is down at that time, let's say you just rebooted it, you restarted the server or something to do maintenance or something, totally fine. But if that replica is down, the coordinator's job is to store what's called a hint. It's just going to say, okay, I'll hold on to the data until you're back. And then when the node comes back online, it replays the hint, which means like it replays any data that was missing and everyone's back in consistency. That's the way it's supposed to work. The bad things that would happen is if your cluster, let's say that you were using those C1 extra larges or C1 larges, and this is like the worst idea ever. Well, you start hammering your cluster with a lot of extra load, bad things start happening everywhere. Well, hints will start piling up in different places because nodes are blinking in and off. It's just, you really have a bad situation on your hand. You want those hints to stick around. In 1.1, there was conditions where those hints would get dropped. And so whenever the nodes came back online, it would replay not all the hints, which means you have to do a repair. And that was, that's okay, doing a repair is a normal operation as well, but it's just one more step in trying to get consistency correct. And it's hard to predict. So in 1.2, hints don't get dropped. They're stored durably until that time that we can replay those. That was a good change. And mostly it's just protection when you're doing bad things.
When things are really hitting the fan, to remember that that's stored in a system key space, or that's node local. And occasionally, very occasionally, I don't know if the docs ever explain when this is necessary, but you'll get a node that'll get stuck in a weird condition, and you need to be able to remove those. And I've had to do it before, where you go in and remove those. It's very rare, and you shouldn't do it unless you really have to recover that node and not just rebuild it with a repair. But that's where it's stored. That's how the storage engine does it. It actually stores it not necessarily.
And does the hint contain the actual data, or just kind of to say, hey, you need to talk to your
It's the
replicas and...
It's the mutation. It is the mutation. So as is that mutation is given by the client to the server. It says, hey, store this, and that's going to be everything from timestamp and column and key and the whole bit. If it can't do that, it'll store that exact thing in the hint table. And it's just the one mutation.
Why
Because it
does,
has to replay.
why does it do that as opposed to just telling it you need to sync up with your replicas?
Because they have to go through all the Merkle tree exchange and it'll take forever.
It's much more efficient.
It's,
The other
it
thing is
saves
split
time.
brain scenario potentially too. I mean, you have to be partition tolerant. So what if you can't get to some nodes, but you can get to this one? So replaying hints is not something you want to count on all the time because they're not going to last forever.
It's especially important if you're running a CL1.
Yeah.
If you're doing really high volume inserts, you want to be at CL1, that's where the best performance is. And that's where hint and handoff really starts to pay off, because even if you have one of the replicas fail, the hints will get backed up and then they'll get replayed onto that node when it comes back online, and you're not constantly going in and repairing your cluster because of single node failures. You should be able to remove any node in your cluster at any time.
This goes back to the dynamo paper. Hints are part of the dynamo paper. You gotta trust the dynamo. All right, next. Someone come on now, we can't be hogging all the questions now. Yeah, go ahead.
Question. So, if you have a row, if you delete it, is it possible to reinsert with an old timestamp?
Yes.
How will you do that?
There's, in Thrift, you can actually, well, no, in all of them, you can overload the timestamp. You can put in your own timestamp.
Okay.
Just make one up.
In any version.
CQL has a timestamp, using timestamp.
If we are not using CQL.
You can use, well, with Thrift for sure. You can do anything with Thrift.
Will that blow into Tombstone?
Yeah,
LWW
we were having the problem with
I think
tombstone.
that's what he's getting at, is that the Tombstone still has a higher timestamp.
The grace period of the tombstone was causing something.
Well, if the timestamp is older,
Yeah.
then the tombstone still stands.
Yeah, you need to use another timestamp.
You need a newer timestamp to get rid of the tombstone.
There's
Because
no any way to override that.
To overwrite the tombstone? Yeah, reinsert the data.
Yeah, if you're reinserting the data, you just use a current timestamp.
Yeah.
Yeah, but the idea was to, in this case, we wanted to, because we are abusing of the timestamp, so we needed to reinsert that same row with the the oldest timestamp that we had.
Oh, are you using the timestamps in your application?
Yes.
So don't do that.
So there's an anti-pattern. Getting
That
fancy
makes
with
sense.
tombstones and timestamps.
I was going to say there are some neat things you can do with the timestamps. The reason why you can override them is if you want to do, say, if you've invented your own version of vector clocks or some of these other fancy distributed system things like CRDTs, you can actually put your own value inside the timestamp and use it, and then you get all the same conflict resolution. But using that timestamp in your application is, it's a big anti-pattern.
If you're gonna go there, know the rules. The rules are last right wins. If you want to break the rules,
Last rate wins.
last right wins. Yeah. Guess what? The rules still apply. You know, it's like gravity, right?
Last rate wins has its problems, but it stands consistent.
Yeah, it is what it is. And if you want to try and get rid of it, there's probably some, if you're going to get that fancy, there's probably some other fancy ways to take care of it. Like change your GC grace to like 0 and, delete your data. Yeah, no, don't get, I've got plenty of data.
I was going to say, you could, if you did your a compaction,
You do a major, you change it to 0, do a major compaction, and then write it again. Yes, totally doable. Go there again. Call me later.
if you're stuck and you need to get your application back online, do a compaction, then write your new value, and then you'll be fine.
The compaction will get rid of it if you change.
That actually leads me to a second question. So.
Okay, well, hold on. We've got another one right here.
What about heap space? I've experienced a lot of troubles with heap space.
On which
One
version?
time in version 1.1, I was not able to make import of data, even small data. Was
Through a
always-
client or using SSD?
No, simply the SS tool of Cassandra.
Yeah.
The
So
first.
that tool is limited to, or it doesn't set the heap size inside. It's just a shell script, the actual command you run, then it loads a Java program, right?
Yes,
And
but
when
I
we start-
tried it. But
When we start Cassandra, we set the heap size typically to 8 gigabytes. And most of those tools, they don't actually set the heap size, so they get the default JVM heap size, which is 1 gigabyte at the top. There was a little 2. So I think it's one gig. So sometimes you need to edit those scripts, and right after the Java command, add a -x and a max.
So I have to make in the script to launch Cassandra or the script to launch the tool.
So you basically do sudo vim user bin ss table loader, or whichever one you're using, and this isn't recommended. We got to find a way to fix that because
Well, you
I've heard
said-
this one a bunch of times.
You can set the environment variable for XMX and
Oh,
Java ops.
Java ops, yeah.
Yeah, the Java ops.
Java if space that.
No, the Java ops is an environment variable that the JVM will read.
Okay.
And what you're going to do, this is just like if you're trying to run a heat dump.
Yes,
in
but I
Eclipse.
tried to do something was wrong. Okay, the next is the same if space problem. Stop to work, the server go down. When I restart, was not able to restart it for heap space error and a lot of cache because was a cache in the file system.
The save cache.
Yes,
Yeah.
but was not able to start because can't for the same problem, heap space.
All right,
It's the same problem.
the same
I
problem.
tried in every way to enlarge this heap space, nothing.
You
So,
didn't have a lot of physical memory on that box, I'd imagine.
sorry,
It wasn't a lot of physical memory on the box itself, on the server,
4G.
or gigs. Because the only time I've seen that in that case is when you had a very limited server size. I mean, it was very limited amount there.
Well, yeah, Cassandra's going to default to half, 4
Quarter.
gigs. Quarter, so 1 gig of.
1 gig of space.
So yeah, you have a lot of
You would
data.
overload it and say, because, yeah, the way that the Cassandra startup script works is it looks at your physical memory, 4 gigs, and takes a quarter of it right up until 8 gigs and then stops.
Are you running Apache or DSC?
Sorry.
Are you running Apache Cassandra from like Planet Cassandra download, or are you running DataStax Enterprise?
I think it's open source. The open source.
Yeah, Apache,
Carbo,
okay. So you're going to look at a file in etc Cassandra Cassandra-e and b data stage, and there are 2 variables. It's documented in the file. There are comments in there. It's just a shell blob, and you'll see there's a max heap size you can set, and you want to set that. I would set it to probably 2 gigs on a 4 gig machine, but maybe 3 if you really need to. But I wouldn't go much higher.
OLM would take it all,
I don't know, maybe some specific to my environment, but I was trying, I changed the script to give more heap space because I think the script calculate by itself, no? It's right. So, and I changed manually the values, nothing.
The other way you can fix it is just delete the saved caches.
And it'll just regenerate them.
They'll just regenerate. The saved caches are convenient. They're not important. So,
No, it's important because when I start up without cache and delete the cache was not data, some data was missing inside.
that's
So
a
some-
commit log. Yeah.
So that was not funny. Okay.
Save cache is just that it's meant to, whenever you start the system, it indexes all your files, okay? And that save cache keeps it from having to redo that operation because it's pretty heavy.
Takes a
You
long
can delete it. But commit log and data are not optional. Commit log is data that did not get put into an SS table. And SS tables are in your data directory. Those are the durable part of your data. If you delete any of those, then you don't have data. You have to run a repair if you're in a cluster. If it's a single server,
Single server, single node, the
Yeah.
simple application, very few data, nothing, almost nothing inside.
Yeah.
Yeah, save caches.
So one
usually-
table only.
It sounds like maybe you got a commit log by accident.
that's, I guess,
Don't know.
yeah. Bring up the laptop, let's go. All right, next.
Okay, one question.
One right there, and then you.
What? You are.
Oh,
Go ahead.
go ahead.
We'll get to it.
So, what's the best approach if you have like if we need to do significant amount of deletes from a table? So we just realize that if we do this just by like deleting objects, then it's like significantly drops the performance after even just a couple of thousands of deletes.
Are you deleting across a long range of time? As in, if you've been inserting data for a couple months, are you deleting stuff that might be a few weeks old, or are you just deleting stuff in recent history, like in the last hour?
Rather recent. recent
Because that
stuff.
sounds like
And
a
then,
good case for LCS.
The only thing which like helped was like dropping the garbage collection period, or
The GC grace.
increasing. That helps, but of course it has a drawback that when like the maintenance restart or something happens, then these old
I'm gonna guess.
zombies start
Right.
appearing in the database.
The delete operations are running. And what my guess is that you are not keeping up with compactions when you're doing your deletes. Because you're probably, when you write your regular data, you're keeping it at a certain pace. But whenever you're doing your deletes, you're just turning it all the way up. And you're running it as fast as possible. When you do a delete, it's going to fill up the mem table, which needs to get flushed. I would almost bet you that if you looked at your system while you're running a full fast delete like that your compactions are backing up, your heap will start filling up because flush writers are pulling up. Look at TP stats. TP stats will show you very clearly the flush writers block threads.
Okay.
I would almost guarantee that's what you're saying. Your disks are not keeping up with that load. Because I've seen people turn deletes on to full blast, and that's basically like a Cassandra stress test. And because it's not your normal application load, right? You're just doing it as fast as you can push that data in there. Because that's really just a write. And compactions have to keep up with that.
Have you messed with the compaction throttling at all?
Well, we messed, but I can't really confirm what we did. So I have to go back and check that one, yeah.
I've had a couple cases where I have to turn off compaction throttling and just let it take all that out. And if you're doing a lot of deletes, it might be worth trying that.
Yeah.
Because that would actually let it just use the full bandwidth of the disks. It's not going to try to be nice to anything else in the system, or even inside Cassandra. And then you'll have a much better chance of keeping up with the compactions. And then if you're on LCS, just make sure you're careful about your SS table size, because you're going to be doing a lot of compaction. Means you probably don't actually want to do. I usually recommend bigger SS table size in megabytes. It's in your schema. You set that. You can set it. It's in the. You can. It'll be. I'll talk about it in my talk too. I usually recommend bigger, like 256 megabytes or 128 megabytes. But you might even want to go smaller, depending on your total data size, and go with 32 or 64 if you don't have a lot of data per node. And then you'll get a lot more efficient compaction.
When I hear the words, and this could be joke, I'm doing a lot of writes and everything starts slowing down, compaction.
Okay.
You just had a disk problem.
Yeah, we're gonna try it.
9 times out of 10, that's the issue. Let's see, so we had that, do you remember the order here?
Back.
And then you, and then in back, right? But in back, you. Hold on, back first. Go ahead. Red, checker, yes.
I'd like
We're
to
doing training.
prepare better. I know they create a Merkle tree for
Yes.
each column family, and then the Merkle trees get copied to the node starting the repair, and that's comparing the Merkle trees. I would like to know how much percentage of the column family is represented by one leaf, and if one leaf doesn't match, how much data will be transferred and reinserted by the nodes. Because I feel sometimes it's like a really big amount, a lot more than I would guess that's broken, will be retransferred.
Yeah, so the beginning of the repair operation builds the Merkle tree by comparison. So it's not that it's transferring it, it's building it. And then once the Merkle tree is built, then it says, here, now this is what I need. And that, the Merkle tree creation is the heavy CPU part of that.
And then
And
they
this
compare.
very often.
Well then,
If it has to read,
yeah.
yeah, it might cause a lot of read I/O. Very often does.
The Merkle tree is ready and done.
It should be done.
Yeah, and then after
Yeah, because
that,
that's what happens is the initiating node will contact the node it needs the Merkle tree from. That node will go off for a while and go and calculate the Merkle tree and then transfer the whole thing over. And then the node doing the repair will do the comparison in memory.
yeah, and after that it knows all the elements that's broken.
And then it'll
But it
start
just
asking
knows-
for the stuff it needs.
Yeah, but as far as I understood, it just knows the range of multiple row.
I don't know the Merkle range. I don't know the ranges. I think that's a good question.
How much is
That's
yeah,
a
how much
branch
data is represented by one leaf of the tree,
Right.
and how much network traffic is created by just one row not matching.
I don't know.
Dig into the source.
I don't know how much it's grabbing. I do know that the network traffic is rarely in the Merkle tree. It's always in the stream.
After that,
Yes.
the real repair.
Yeah.
That's the beauty of Merkle trees, is they're really tiny
They're
for,
tiny,
for the amount of power you get out of them.
The heavier operation, and this is actually a big deal with Streams 2.0, which is in Cassandra, is how the streams get managed by the system. And the other part of repair that people don't really get is that when you do a repair, that immediately is flushed to an SS table, which will create a lot of compaction at that moment. And a lot of people say, well, I just ran a repair and all of a sudden I'm doing all these compaction, what gives? Well, it's because when the mem table gets that new data, it flushes it out immediately. There is no waiting for that. So repair operations will do a lot of it.
Is there any way to influence, to do less?
Yes.
I mean, if I have smaller leaves, I could do less flushes.
Changing the type of repair you do, like a PR, you're doing a partition range, or changing the streams. So the streams value sets that stream throughput, changing that to a really low value, so it's just kind of smoothing the value very slowly. And the stream throughput is the from. So if the sender, that's from the sender that you set the stream throughput. So if it's comparing, it says, hey, I'm missing your data. The data that comes from that node, you can set the throttle. So you can throttle it way down. Yeah, when you set your stream throttling down to a low value, it's going to take longer to do the stream of data over, but it won't overwhelm anybody if it's not.
Thank you.
Okay, your turn.
Going multi-data center and using SSL, you can use SSL to connect them up. And the documentation on using SSL indicates to a key store along with a certificate and etc. for every single node, which seems like quite a bit of pain if you want to add one node. You've got to go around every single box and add that in. Are there any recommended approaches for doing SSL with multiple data centers which makes life a bit easier?
I've done some experiments using Tink instead, which is a little VPN daemon for Linux. That's really, the documentation is terrible. Been working on a blog post for almost 6 months just trying to figure out how to do it, so that I can give it to you guys and let you run with it. So that's one option if you really need encryption, is to do something like that, like Tink or IP. I don't want to say IP stack. That's just mean. So there's that, or finding some kind of a certificate management system that might help you with that. So something like a CertMaster is an open source Python project that generates certificates and passes them around for you. I'm not sure if that's exactly an application. It's on my to-do list to try that actually. So yeah, that is a pain point. It's just it's a pain point in every part of crypto, everywhere, especially for peer-to-peer.
Is that why often generally going for VPN instead of going for SSL in these kind of environments?
I think that's just because network administrators tend to prefer VPNs.
Well, it simplifies the stack. Not having to pass around SSL certificates is a win for less complexity. The
other
things that
side
fail are
is
complex usually.
the Java crypto is not bad, but it's nowhere near as good as the hardware crypto stuff that VPN devices do. So using Cassandra's crypto, it works and it's there and it's a feature, but you're going to get way better performance out of a hardware VPN device.
You shouldn't have any latency on hardware.
And even some of the local, Linux VPN software, OpenVPN or Tink, will use the OpenSSL stuff. And if you're on a Westmere or higher or Haswell, you'll have the AES-NI instructions on the chip, so it'll actually be accelerated in hardware. So in Java, there's instructions around various places how to get it working. And I was looking at that a couple weeks ago, and it's really ugly.
Security's hard. That's why we just don't do it. Encryption at REST, hey, awesome. All right, yes.
Solar integration in DataStax enterprise.
Is that a
Can I ask
question
a
or a
question?
comment?
Purely Cassandra.
Yes.
We have
all right.
So if I create a schema in Solar and have a column family then created in Cassandra, there's two things that stand out in the schema description. One is it uses compact storage, and the other it creates secondary indexes for pretty much
A lot of
every single
secondary
field.
indexes.
Why those two things? Why compact storage and why secondary indexes?
All right, well, the compact storage, because composites are, or I'm sorry, CQL is not something that's understood by Solar yet, that's being worked on. That's a different type of structure. So compact storage creates a CQL-less column family. And the secondary indexes are how it finds data. So the data that's being managed by the schema in Solar has to be understood from a column family perspective, meaning that it needs to know where all the columns are and the values in them. So those secondary indexes are created by the schema creation of Solar. So it's how it finds the data once you index it. So the indexing is just is how do I find the row key? Then the secondary index is how do I find the row key with that particular column with the value. So this is how it does its indexing. So it's just a different way of managing data on top of Cassandra. Solar should be super fast, but it has to index the data first, and that's how it gets the data.
I think the impact of that is I can't use secondary indexes and Solar on the same column family.
Yeah, you should really consider that column family a Solar column family, mostly. You can use data on there normally with CQL or with Thrift, even some CQL2 stuff, but Thrift mostly. And the idea though is you should really have if you're going to be doing CQL-like operations, denormalize it into a different table.
I think my concern there was if I manage the server, the database on the server, then and have other people write client code, they might think, oh, there's a secondary index, I can use it, and that will kill my performance.
Sure, you can use it. Don't count.
Is
It's being managed by
is there any way to kind of prevent them from can I make that secondary index usable by Cassandra but not usable by the outside?
Oh, like hide it from them?
Yeah, there's no security that would do that. It's still there, and that's why I say create another column.
Yeah, if it's a separate column family, you could use the permission stuff to restrict access to that column family.
But you're not going to do column level restriction. You can't.
No, it would have to be column family level.
Yeah, it's row.
Okay, cool.
Something over here, yes.
Yeah, this morning you said that we should never use shared storage.
Ah, yay! I'm glad I asked that question.
Never,
Go
ever.
But does this apply to small clusters with virtual machines and storage area networks? Or is that a completely separate world?
You mean like a Fibre Channel network?
Yeah, something like
I had this question at lunch.
I mean, the real answer is it would work.
Yeah.
We still don't recommend it. I mean, it's going to cost you a lot more money. The commodity storage, you can get SAS disks that are just as good as what's in the storage array. You can get pretty close to equal support from Dell, HP, any of the major vendors. And you're going to get it at something like 1/10 of the cost of any of the SAN gear you can afford, you can buy. If you work at a place that really insists on all disks are on the SAN, there are places out there. I mean, maybe you work at one of them where...
Right, the thing is we already have this SAN array, and we're wondering if that would kill performance on a small cluster we are building.
Well, it could. Maybe this is more of a warning. Just understand that the limitation. So, in general, Cassandra is limited by one thing almost always. That's I/O. I/O is the bottleneck.
What kind of
Not
storage
CPU, not memory.
I don't know.
Is it like high-end, middle tier? Or
It's middle tier.
Because on some of those, what you could do, if you really need to use the gear, right? You've got it sitting there burning a hole in your pocket.
Right, we don't really need to use it. We are just wondering if that's, because in production we will have a completely different requirement. So we are wondering if you can run tests against that and compare it maybe with all of these machines.
You could, yeah, sure. And what I would do is, if you have the ability to carve custom LUNs on the array, I would actually assign spindles to Cassandra. You can do the RAID on the device, so maybe do a RAID 10 set, do another RAID 10 set, do another RAID 10 set, even inside the same array, but assign each one to a different node, and you can zone that all off and the switches and all that happy stuff. And then you're pretty close to having local attached disk, and if it's just a science project, or a dev cluster, then I guess go for it, but it's definitely not something that we recommend.
So in production you would recommend that each machine
Has local storage.
And an SSD preferably.
SSDs, if you want really consistent latency, if you're going spinning media, I recommend SAS very highly over SATA.
SAS is where
SAS is the I want to sleep at night option.
Right.
Yeah.
It's a warning because I in my job with DataStax as a solution consultant, whenever, and I get into phone calls with people that are in really bad place. You know, they've gone down this path and then they, you know, maybe got to a point where they're having real big problems. We had a customer, I can't name names, but we had a customer call us on a Sunday night and said, we just went live and there's a fire in our data center. Help us now. We were there the next morning. The problem was they were using this really shitty shared storage system. It was all NFS. And you know, this is why I threw out this morning, because I want you to know ahead of time.
NFS, if you'd asked NFS, I would say absolutely
Never
never.
use NFS, because it's just not made for this kind of stuff. But I'm throwing out this warning just to make you think, and you're thinking now. You're going to be like, okay, I'm going to keep my eye on it. You're not going to be surprised.
So Fibre Channel is a different story.
Fibre Channel can be different, yeah.
So
they're all the
iSCSI,
same.
absolutely not, right? That would just be a disaster. I don't care which one. I mean, there are some really high-end iSCSI devices that have good enough latency that you're not going to get in a lot of trouble. But generally, those devices are made for a completely different kind of animal than Cassandra.
Yeah, it's not a blanket like it'll never work. It's just be aware.
Yeah.
Keep an eye.
It's going to be painful.
Yeah, treat it like that really mean pit bull dog. Like, you know, nice doggy. Okay, don't
Don't look away and walk softly.
Don't play with meat around it. Yeah.
This might be another anti-pattern situation, as a heads up.
That's why we're here.
It's about repairs and operation and maintenance operations. In our cluster, we have a cron job that runs a repair every week, and it takes a lot of time. It's quite heavy. And my question, actually, two questions. First, is there a way to orchestrate this? Is there a better way to manage this? And the other is, when should we do it? And yeah, because I'm not sure if 1 week is enough, or it should be short.
Well, it depends on your GC grace, right? Whatever your GC grace value is on your schema, that's the time window you have. And I like to always have mine be where I have a really big buffer before I'm going to hit GC grace. So at Uyala, we set them to, we started with 90 days, and we screwed that up. And so they're at a year now, but we would do the repairs every month. So because, you know, when you have a 36 or a larger cluster, 36 node cluster, and you're rolling through and doing, we could do one a day. It took about 24 hours to do a node, so it would take about 36 days. So we just basically kept it going all the time around the ring. In terms of orchestration, I've heard that certain products might be supporting that soon.
Yeah, no, is
that public?
We're talking about that. Yeah,
Yeah.
Op Center has a thing called, it will have a thing called Smart Repair or Repair Expert, and it will continuously run repairs in the background in an intelligent fashion. Part of the pay-for option with the
That's
Xbox.
great.
Yeah.
And then the other one is Creum, I think supports.
Other thing that we've been seeing,
What's that?
other thing that we've seen in the repairs is that sometimes it fails and there's no way to retry it, and most people there.
The repair.
Yeah.
Yeah, there's ways you can do it. You can there's a new option in 1.2 in Node tool called Calculate Splits, and you calculate the splits of your token ranges, and it'll only do the repair on a small token range. And that's so if you want to spin your own, just bust out a ton of those splits. Say I want to split up 100 different ones, and you can run them in parallel. Doable.
But if it fails, it will retry or something?
No, you just retry that one range. You don't retry the entire thing.
Ah, okay.
Smarter, right? Oh, wait. Smarter care. Okay, so now you know. Catch on.
Does Cassandra have a maximum size for local storage for node?
The maximum size of a
Local
cluster.
storage for node? Yeah, per
Oh,
node.
per node.
Node.
Depends on your storage system.
So I can go as big as I want.
Huh?
I can go as big as I want per node.
Well, there's probably an upper limit. It used to be 200 gigs was the recommended upper limit. And back in that day, I was blowing way past that on all my clusters. Uyala's main or oldest cluster is at about 500 gigs per node right now.
I put 5 terabytes on a node.
Because I thought
But yeah, if you're on SSDs, yeah, 5 terabytes isn't a big deal. It's just, you know, if you need to scan over all your data, you just realize that your spindles are going to be, you know,
The limit?
it's just all about I/O, right?
yeah.
The limit is when you can no longer keep up with what you have. If you have a lot of cold data, maybe your latency requirements are different. I mean, there's so many different variables. It can store a lot of data on there. It's not going to fail. It's just, what is your SLA? If you're looking for 10 millisecond SLA on all your reads, then if you put 10 terabytes on a node, you're not going to get that. It's just not gonna happen. But
if you have 10 terabytes of SSD and you're okay with 100 milliseconds, that might work out.
it might be fun. Yeah.
How much RAM do you need for that?
Hmm?
For 5 terabytes of storage, how much RAM?
RAM, as much as you can put in the box, 128
Yeah.
gigs, you know. But
128
it
or
depends.
56, yeah.
You could put 32 in there. But
Yeah, if
what's
you're-
your SLA for your? I mean, it's all about managing the read SLA.
If you're sitting on a really hot SSD, you know, a high-end Intel or a Fusion IO or something like that, 32 gigs would probably do you fine as long as the latency of and accessing the SSD is good enough for you.
Although you've moved them off heap, there's still in-memory structures that have size proportional to the amount of data on them.
It's OS buffers, and those OS buffers are going to be how fast you can read. You're just going to
So you're relying on swap space.
You're going to be,
We don't-
not sweat. Turn
It's
swap
gonna
off.
pay
Swap is off.
Swap off. Always swap off.
Never use swap.
Unless you're
As
under
you
8
add disk,
gigs.
you have to add RAM in proportion to that.
Yeah, unless you're under 8 gigs, but then you're never going to have good performance.
Yeah.
And so basically, if you need swap, then you need to put more RAM in the box.
So you're bringing in points that would say, oh, that's a performance problem. Okay, then don't do that. And you can. I've put a lot of data in Cassandra. I've packed it in there, but if you're looking for performance, that's a different profile.
Yeah.
You know, it will swing the difference in that.
And if you have time series, for example, is a great one.
Right.
You can lay that stuff out on a disk. It goes cold. You don't care. You're never going to delete it, and you just let it sit there.
And some of the new compaction strategies that are now in 2.02 that are coming out next week. Well, actually, there's some of them that have been since 1.2. The new compaction strategies where they look at time series data and they don't recompact it ever. Those will make it so you can really put a lot of data on there because compaction is what is really the name of the game.
Yeah, if it's sparse access, then
Yeah.
you know you can do, you know, the big lumbering nearline SAS drives. And
Yeah,
sure, you're going to be 500 milliseconds a second on an access, but if you can live with that, then
yeah,
go
the
deep.
idea is
Go
10
deep and
terabytes.
cheap, right? Because then you got cheap storage.
That's the idea actually.
Yeah.
That's actually all idea to throw a lot of storage to sort of build, say, the Cassandra cluster with a crap load of storage.
The other thing I really like in a config like what you're talking about is ZFS. ZFS on Linux even.
Yeah. Go to his talk later.
It is that, if you're dealing with that, if you want big storage, I really highly recommend looking at ZFS on Linux.
Go to Al's talk later if you want to learn about how to make disks really happy. Al's the man.
Back here, you've been waiting.
Yeah, mostly because I've made problems for myself. We've got a customer running in production with a data model that we obviously were not supermodels with, and are having them to migrate it onto new data models. And so we had to migrate several tens of terabytes of data from one data model to another. Well, we've done it, but is there a better way to do it than
Moving data from one model to the next?
Yeah. There's no tools or anything, I mean...
Well, sure there's tools, but at that point I just prefer to write custom code. I mean, it could be, you could do a kettle, like as kettle, which is pretty decent, but yeah.
And I'll be talking about the really crazy stuff we did at Uyala to do something like that. We did the absolute craziest hardcore nerd thing you could do, which is we pulled the code out of Cassandra to read the SS tables directly and ran a MapReduce job over all of our SS tables. But we were back into a corner. We had to do it. So.
And they wanted to do it the hardest way possible for bragging rights, I think. Because they came out and they're like, you know what we did? I'm like, really? That's wrong with you people. I would never do that. I mean, running Cassandra, re-optimized Cassandra code inside MapReduce.
Oh, we didn't optimize it.
Live it out, dude.
We just let it suck.
Street credit for that. You're right on.
Just let it drag on.
Cool. Yeah, just let it go. All right. So yeah, in the corner.
Okay. There are a couple of ways to work with Cassandra, like Swift, SNS, and now DataStax is like pushing a SQL driver to use it. Does it mean that SNX driver is dead?
No. Astanix driver is alive and well. Puneet and I, Puneet is the guy who's maintaining it now. Ron is no longer doing it. Puneet and I are working well together. We're trying to blend the two things together. Netflix doesn't want to be in the driver business forever, but the Astyanax is a very robust driver for what it does.
It's a lot more than a driver.
It's a lot
got
more
a lot
than
of recipes
Yeah, I know,
built in.
but
So
my question was really.
It's not gonna end the life. They're not gonna put it in mothballs and just kill it or anything like that.
Yeah, it
They're
doesn't
gonna
mean
back
that the DataStax will kill the underlying protocol that Astyanax works with Thrift, like.
It will work with both Thrift and native. That's their goal. Because they have old code, they're not going to change. It has to support the old code. So it might actually be the better choice if you're running Thrift and CQL at the same time for a lot of reasons. So that's what they're trying to do is make it so they can move forward but stay behind as well.
Astyanax is one of our most popular clients. Probably still the most popular.
Recipes are cool.
Actually, we do both. We do SQL stuff, basic SQL stuff, and then we run Astyanax.
Yeah. It's really not anything they could get rid of. They have too much investment in what they're doing right now. I mean, their entire stack, $1 billion business is running on Astyanax. You can't just shoot it in the head, definitely. Yeah. So how is that for an answer? Go ahead.
Evil question.
Oh man, we had to have an evil.
Yeah, in the owner's manual, there's a very fine line of fine print that's relevant mostly to I think the setup where you just have one huge column family, its size, tier, compaction, and then if you manage to run over 50% and you can't compact the largest one anymore, then you're basically totally into trouble. We basically ran into that the second time. Is there any way to save the cluster because you can't even compact the stuff away, even if you delete the rows, because it won't compact?
Yes.
Move it to bigger disks.
Well, yes. The SS tables, all right, so SS tables are immutable. And because of that, you could still, what I would do with that data is I would take those largest SS tables, move them to and expand the size of your cluster, like add new nodes. Take that existing SS table, the big one, to a different node and run bulk loader, and it will restream that data into a new data structure across the cluster. That's kind of a bad way. I mean, that's a long way.
I mean,
but it's doable.
You could do stuff. I mean, if you're really strapped, like you can't get more hardware or anything, stuff like that, you could do things. I suppose you could replace nodes, start rebuilding nodes, and use repair, and then switch to LCS. And so you get the cluster completely healthy, except for the fact that you can't compact.
That's 50% of free space.
Shoot a node in the head, rebuild it, put it on LCS, and then repair, and then it'll basically rebuild on LCS, and then you don't have that problem anymore.
You could do it without bringing your cluster.
That would be totally evil. I don't think that's supported, but it would probably work. So
I've done weird things on consulting. Especially when you have someone who's like, no, you don't understand. Our business is running on this. We can't bring it down, but we do this really board thing.
Yeah.
Help us make a deal with the devil and help us get out of this. And so that is doable because it really comes down to the fact that the SS tables, that's your data, have a lot of options because they're immutable. And that is all your data. And you can take those, there's a thing called GetAllRed, which you can take all those SS tables and put them on a different server and reboot it, and it'll just read everything. Like, I own all these files. There's some options. It's not the way you want to do it all the time, but when you just can't do anything else, there's options.
yeah, we had a cluster once where we pulled all the SS tables from all the nodes onto all the nodes, and then did a cleanup.
Yeah.
Because we knew something was messed up somewhere in the cluster, and we looked and we said, we have enough disk space to just do this crazy thing. And so we just pushed all the SS tables everywhere and then did a cleanup, and so it went and did a shitload of I/O for like 3 days. And then when it got all done, the disk space all came down, and then everything was clean and nice.
And the sun came out,
but that's
birds
just
chirped.
Well, it was more like, you could kind of sort of see the sun, and you weren't breathing water anymore. And
yeah. I've gone through plenty of the scenarios. Cassandra is wonderful. I mean, it's easy to just beat on it, and then it'll recover eventually. But man, just don't get in those situations, please. What are we out of time? Are you monitoring our time?
No.
I was waiting for you to tell me whenever. All right, 3:30. What time are we?
We're halfway through the break.
3:15 is the break.
Oh,
shit!
Sorry, my friend.
Sorry, guys. It must have been that good, huh? Yeah. All right. So that's weird. All right. So that means that if 3:15 is a break, when's it over?
3:45.
All right,
Oh,
so
we got
break time.
Break time, guys. Are we good?
Yeah.
People are becoming just like guys.
Now
get out.
she tells us.
Get out.
And the Meet the Experts room is open if you have more questions.
Yeah, Meet the Experts room where